Assalamualaikum. My name is Muhammad Syafiq Adam. I will present about PPM, position pass modulation. So we go to theory. But the basic of PPM is from the pass modulation system represent a message bearing signal by the train of pulse. So it have four basic pass modulation technique. First is pulse amplitude modulation. Second, pulse rate modulation. Three is pulse modulation, position modulation. Four is pulse density modulation. Okay, so our group got title of PPM. So we focus about PPM. PPM is pulse position modulation. It is a modulation technique designed to achieve the goal like simple transmitter and receiver circuitry, noise performance, constant bandwidth, and the power efficiency, and constant transmitter power. It also the amplitude of the pulse is keep constant as in case of the FM and PWM to avoid noise interference. So it have a sine wave generator and ramp generator. We go to the comparator. So for comparator, the output is PWM. So the PWM we enter the monostable, it will give output of PPM. It easily generated from a PWM waveform which has been modulated according to the input signal waveform. Generate a small pulse of constant width at the end of the duty time of each and every PWM pulse. As you can see, the diagram show the waveform. So the waveform have three modulation, which is pulse amplitude modulation, pulse width modulation, and position pulse modulation. So it have a parameter which is modulation give type of carrier is train of pulse. So this three modulation give train of pulse. Then next parameter is variable characteristic of pulse carrier. For PAM give amplitude, PWM is width, PPM is position. The third parameter is bandwidth requirement. So the PAM is bandwidth requirement is low, PWM is high, PPM also high. So next parameter is noise immunity. Noise immunity for PAM is low, PWS is high, and PPM is high. The bandwidth, next parameter is bandwidth depends on PAM, which width of the pulse, PWM, rise time of the pulse, PPM also rise time of the pulse. Okay, how PPM works? It requires both devices to be synchronized to the same clock so that the device decode the information when the pulse will broadcast when a series of pulses are sent. Then it allow encoding of all signals based on the difference between broadcast time.
Hello, my name is Ashraf. I'm presenting about the literature review and the discussion of this subject. So, PPM is a circuit that converts digital code into a time reference with respect to the reference clock. So, PPM circuits are used in many applications such as in impulse radio, ultra-wideband radio, and radio communications, where in time-based serial communication links. In the transmitter circuits, modulates each clock pulse in time according to the input bits, and the receiver circuit converts the time difference between the received signals and the reference clock signal into a binary code corresponding to the transmitted bits. Time-based architectures such as use much lower input clock signal frequency compared to the conventional SerDes architectures. It consumes less power, which simplifies the transceiver design. Then the proposed circuit as shown in the figure uses one delay line and loading MOS capacitor, which is C0, C1 up until Cn-2 and Cn-1. They are designed to provide linearly spaced delay. The MOS capacitors controlled by the digital switches. The input signals, which is the B0, B1 until the Bn-2 and Bn-1 to the digital switches, are the input bits, and the input signal to the relay line is the input clock signal. Each clock pulse is modulated in time according to the input bits. Using MOS capacitor, as you can see from the diagram, allows programmable high resolution delay values. A separate clock out signal is also generated to allow the demodulation of the PPM out signal. Then, another implementation of the high resolution PPM is shown as the figure above. The PPM circuit is proposed by the authors has been modified using a tunable delay element, which is the T. The high resolution differential delay values can be achieved by controlling the DC input voltages VGP and VGN. The proposed circuit can be combined with a low resolution PPM circuit to create a dual resolution PPM, which is the DR PPM circuit, in order to increase the total number of modulated bits per symbol in time-based serial link applications without occupying significant additional bandwidth. Using the DR PPM circuits now in time-based serial links reduces the complexity of the circuit of the receiver design by reducing the required number of bits of the TDC circuit.
Okay, Assalamualaikum. For me, it's the result calculation of the pulse position modulation PPM spectrum. In 1966, Schwartz published in Analysis of Frequency Spectrum of Pulse Position Modulation waveform. Is relate the spectrum directly to the parameter in proposed PPM modulator. In section, the spectrum is rewritten in form suitable for use in HYDE converter. Control analysis. In swatch analysis, the PPM waveform is generated by adding the modulation signal to steady sawtooth sweep voltage. When this sweep is rising and cross a preset threshold, a pulse is generated. The unmodulated sweep waveform threshold and resulting pulses are shown in the figure 1.6. Letting the sweep be as shown in figure 1.2 and the modulation signal Q cos bracket QT, and allowing each pulse to be a delta function B bracket T of area 1 swatch. Calculate the resulting frequency spectrum. This is the formula of frequency spectrum. You can see where P angular sweep frequency, and this is the sawtooth signal, waveform signal. You can see. Okay, we define the PPM in terms of the pulse angular position. M radian as B cos bracket KW 0T plus B minus C result in substitution. So this is the formula for 3.2 is Q equal to negative PB divided by pi. 3.3 is Q equal to K omega, letting P be the fundamental frequency, W0 the frequency spectrum become E bracket T equal to omega divided by 2 pi plus BK omega divided by 2 pi sin bracket K omega T plus dk. This statement of the PPM spectrum form the basis of the analysis of the non-ideal converter transfer function spectra. Okay, thank you. That's from me.
Pulse position modulation PPM possesses the noise advantage of PWM without the problem of the variable power that is a function of signal amplitude. Here are the results of the PPM. An information signal ST and the corresponding PPM waveform are illustrated in figure 1.1. As we can see from the figure, we see that the larger the sample value is, the more the corresponding pulse deviates from its unmodulated position. A PPM waveform can be derived from a PWM waveform. The relationship between the two is that while the position of the pulse varies in PPM, the location of the leading edge of the pulse varies in PWM. Suppose, for example, that we detect each trailing edge of the pulse in PWM waveform differentiate and look, for example, large negative pulse. If we now place a constant wave pulse at each of this point, the result is PPM as shown in figure 1.12. Along with greater complexity, PWM and PPM have other negative properties. If pulses are free to shift around or to get wider as they are in PPM and PWM, we cannot simply insert other pulses in the space and be confident that no interaction will occur. Sufficient spacing must be maintained to allow for the largest possible sample value. This decreases the number of the channels that can be multiples.
Then we presenting about the discussion of this of PPM. PPM or pulse position modulation is a form of signal modulation which M message bits encoded by transmitting a single pulse in one of the 2M possible required time shifts. This is repeated every t seconds such that the transmitted bit rate is M over t bit per second. It is primarily used for optical communication system which tend to have little to no multipath interferences. One of the key difficulties of implementing this technique is that the receiver must be properly synchronized to align to the local clock with the beginning of each symbol. Therefore, it is often implemented differentially as differential pulse position modulation, whereby each pulse position is encoded relative to the previous one, such that the receiver must only measure the difference in the arrival time of the successive pulses. It is possible that the limit of the propagation of errors to adjacent symbols, so that an error is measuring the differential delay of one pulse will affect two symbols, instead of affecting all successive measurements. And lastly, aside from the issues regarding receiver synchronization, the key disadvantage of PPM is that they are inherently sensitive to multipath interferences that arises in the channels with frequency selective fading, whereby the receiver signal contains one or more echoes in each transmitted pulses. Since the information is encoded in the time of arrival either indifferentially or relatively to the common clock, the presence of one or more echoes can make it extremely difficult, if not impossible, to accurately determine the correct pulse position corresponding to the transmitted pulses. Multipath in PPM, the system can be easily avoided by using the same technique that is used in the radar system, which is totally rely on synchronization, and time of arrival of the received pulse is to attain their range, position, and presence of the echoes. This makes it a suitable candidate for optical communication system where coherent phase modulation and detection are difficult and extremely expensive. Thank you.
As the conclusion, the amplitude and width of pulses are constant while the position of pulses varies proportionally with the amplitude of analogical useful signal in modulated signal PPM and its carrier signal formed from a clock pulse. In addition, pulse position modulation PPM has many purposes, especially in RF radio frequency communications. Because pulse position modulation only communicates simple commands from a transmitter to a receiver, it is often used in lightweight applications due to its low system requirements. However, pulse position modulation requires that both devices are synchronized or differential pulse position modulation is used.